This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is part of a series of videos where we're going to be solving more complicated trigonometric equations where we might need to use these methods: factoring, the quadratic formula, or other methods for solving quadratics. We might have to use trig identities. We might have to square both sides. We also might be dealing with multiple angles. Keep in mind that anytime you square both sides of an equation, it's essential that you check solutions for extraneous roots. We're going to solve this equation. Tangent squared x equals 3 tangent of x plus 1 in the interval 0 to 2 pi. So we're looking for real numbers or radians. We're not going to be putting it in degrees. Alright, so this looks like a quadratic, so I'm going to start by subtracting 3 tangent of x and 1 from both sides, so I have all the terms on the left-hand side equaling to 0. Now, this is really in the form, y squared minus 3y minus 1, where y is being substituted for tangent of x, and unfortunately, this does not factor. So we're going to have to use the quadratic formula. Alright, but instead of y, it's tangent of x, right? So the tangent of x, according to the quadratic formula, we've got what? A is 1, b is negative 3, and c is negative 1. So remember, it's negative b, right? So it's the opposite of negative 3, plus or minus the square root of b squared, which is going to be 9. Doesn't matter if you think of it as 3 squared or negative 3 times negative 3, you're going to get 9, minus 4 times ac. So that's times 1 times negative 1, all over 2a. So this gives us 3 plus or minus 9 plus 4, that's 13, all over 2. So we have two solutions here. It could either be 3 plus square root of 3 over 2 or 3 minus square root of 13. I think I said 3, but I meant 13 over 2. So we're going to have to get our calculator out. And we've got to be careful how we enter this, but remember, you use our calculator will just give us one solution in the correct range, in between negative pi over 2 and pi over 2. And this first one, 3 plus square root of 13 over 2, will be a positive number, so this will give us a solution in quadrant 1. So we have tan inverse. I'm going to show you how I would enter this very carefully. Parentheses, parentheses, 3 plus square root, and then there's usually a parentheses here, another parentheses, divide by 2, another parentheses, and then enter. Okay, so that's how I enter this in my calculator to get one solution. And then I'm going to round that solution. So you could do it separately. You could do 3 plus square root of 13, enter it, then divide by 2, enter it, and then maybe take that out to about 5 or 6 digits and then put it in tangent inverse. I'm just doing it all in one fell swoop here. And I get 1.27. So you've got to make sure it's in radian mode, because remember, we're going in between 0 and 2 pi. That gives us one solution, right, in quadrant 1, because that's where the arctangent is defined. But remember, since tangent has a period of pi, you'll get another solution by adding pi to that. So that'll give us one solution, but x can also be 1.27 plus pi. All right, so that'll give us another solution. So let's do that on our calculator. And that gives me 4.41. I'm rounding, of course, to the nearest hundredth per the directions. So far it looks like we've got two solutions, right? Rounded to the nearest hundredth, and we only did this problem here so far, right? But we've got this other one. Tangent of x equals 3 minus root 3 over 2, so we're going to do exactly the same thing for that. So how would I enter that? I'd put in my calculator everything the same. Of course, it depends what kind of calculator. I'm using a scientific one, a TI-30X2S. Okay, and that gives me approximately, let's see, negative 0.29. Well, that's because the range for the arctangent can be in between negative pi over 2 and pi over 2. So I'm going to get a negative number since, and oops, that was a minus I plugged in there. But I'm trying to find my solutions in between 0 and 2 pi. That's the original. So what I want for my actual answers for x, I'm going to call this x1, one of the real solutions. The next one, if I add pi, I'll get something in the right range. So if I take the negative 0.29, or if you leave what's in your calculator, and add pi, you should get 2.85. And then for a third solution, I'm going to take that answer and add pi to it as well, and that'll give me 5.99. And now check out these solutions here. Are these in between 0 and 2 pi? Well, 2 pi, what's pi stand for? Approximately 3.14, so it's a little over 6, right? And I've got all positive values, 1.27, 4.441, 2.85, and 5.99. Those are all values between 0, and 6, basically, right? It's really 6.28 approximately. So our solutions here, remember, you want to write the answer as what was asked for in between 0 and 2 pi, so you don't want to use this negative 0.29. So we've got 1.27, 4.41, 2.85, and 5.99. Now it's easy to make a mistake, so let's check at least one of these in the original problem. So here are the 4 solutions we got, and let's just check one of them. Now remember, we rounded to the nearest hundredth, so it probably is not going to be exact. It absolutely is not going to be exact, the left-hand side and the right-hand side. But we're trying to see if we're sort of in the ballpark. If we would have gone out to maybe 5 or 6 decimal places, we would get closer and closer. All right, so let's put in the tangent of 4.41 and square it, since that's what that means, tan squared x. And you can plug that into your calculator, make sure it's in radian mode, and let's round to the nearest thousandth. So I got that that's about 10.276. It's just an approximation. And now we'll plug in on the right-hand side. Make sure you're doing your order of operations very carefully when you are using your calculator, and go ahead and put that in. 3 times the tangent of 4.41, and then add 1, or you could write 1 plus 3 tangent of 4.41, and I got 10.617. So we're off, but we're sort of in the same ballpark. So you can't tell for sure, but this gives you an idea. Like if this was like, 10 and this other one was 5.3, that's really far off. But here we are at least, the whole number part is correct. So you could do that for 1.27, for 2.85, 5.99. You could also go back and see what happens if you had rounded this to 5 digits after the decimal point, how much closer you would have got when you checked it. So these are pretty involved problems, aren't they? You have to know how to use your calculator carefully. You have to remember if your answer is between 0 and 2 pi, you're going to have to, when you're working with the tangent, add pi to get a positive value, etc. You have to think What numbers are less than 2 pi, right? So you'd have to stop at 5.99, etc. So lots to think about. This is your Math Gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.